The greatest integer function. You can see here it's y equals bracket x bracket. The only thing is that's a little bit mistaken. It's actually y equals the bracket actually has like an extra line in it, and then x, and then another bracket with an extra line in it. So please, for this definition box that I have up here, just pretend with me that these brackets actually have this extra line. A plain old bracket by itself usually just means that we can multiply something. So to get the greatest integer function, we kind of need that special line. Certainly that's the way to look in the book. So let's see what the greatest integer, since this is what it looks like, let's see what it does exactly. There's some, oh, here, I love this definition. The greatest integer function returns the largest integer that is less than or equal to x. The greatest integer function returns the largest integer that is less than or equal to x. Please take a moment and write that down. While you're doing that, I'm going to start to make a little table so that we can get an idea of what this means. We've got x here, and we'll have y when y equals the greatest integer of x. There we go. All right. Now, before we do, let's look at some examples to see what this definition really means. By the way, I like this. In essence, it rounds down a real number to the nearest integer. So, if we put 1 into the greatest integer function, we get 1. If we put 1.5 in, we round down to 1. If we put 3.7 in, we round down to 3, and if we put 4.3 in, we round down to 4. Now, remember how negative numbers work. Negative 2 is bigger than negative 3. So if I put negative 2.1 in, I round down to negative 3. So negative 2.1 is right about here, and if I put that in the greatest integer function, I round down to the next lowest integer. Now that I'm mentioning integers, it's important that we get that definition down. Let's make sure you know what those are. Integers are all the whole numbers and their opposites, plus 0. Actually, whole numbers include 0. Whole numbers and their and opposites. That's what integers are. So when we look at this graph here, this coordinate plane, I'm sorry, when we look at the coordinate plane, we can see 0, 1, 2, 3, 4, 5 are all the whole numbers. And the opposites are negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. That's what integers are. They're whole numbers and the opposites. Okay, with that idea in mind, we can now say, well, round down to the nearest integer. Now we have a sense of what that means. So negative 5.5, it's between these two. If we round down to the nearest integer that we round down to is negative 6. That's why it looks like that in the example. All right, let's see how it looks with a table. So let's say we want a graph. If we want a graph, our table is a little funkier looking because what ends up happening is that we get one y value for a range of x values. So what we do is we say, what if x is greater than or equal to 0 but less than 1? Well, in that case, for x being all of these values between 0 and 1, y is going to be 0. In other words, the greatest integer function operating on x takes any of these numbers and converts them to 0. Any numbers that are between 0 and 1 get shot down to 0. So when I go to graph this, it looks like this. I put a closed dot at 0, and then I go almost up to 1, and then at 1 I put an open dot because this does not include 1. And let's go ahead and let's try a few more of these. So we'll try x is less than or equal to 1, and it's less than 2. I'm sorry, x is greater than or equal to 1, x is less than 2, and that gives us a 1. And so again, we go up to y is 1, and we say from x equals 1 almost up to x equals 2, and then we graph. And then we keep going like that. X is greater than or equal to 2, and less than 3. That's going to get us a 2. So we go up to x is 2, starts at 2, go almost till x equals 3. There's 3. And we graph all of this at y equals 2. So that's the greatest integer function. Now let's take a look and see what happens if we do some stuff with the greatest integer function. So what if we take the greatest integer function and we add something to it? So we try something like plus 3. Let's go ahead and see what that graph is going to look like. So again, we could make a table, and when we do, we've got x, and we've got greatest integer of x, and then greatest integer of x plus 3. So it'd probably be worthwhile to have all 3 columns. So again, when x is between 0 and 1, we get 0 as the greatest integer. If we add 3 to that, we get 3. So what happens here is now we go to y is 3 when x is between 0 and 1. So we go like this, and then open dot at x equals 1, because this is only for values that x are less than 1. And then we try again. X is less than or equal to 1, greater than or equal to 1 and less than 2, we get 1. But if we add 3, we get 4. So we go to y is 4 for x is between 1 and 2. So there we go. And then there we go. And then the pattern keeps repeating. So, and by the way, just out of curiosity, let's throw in a negative number just for giggles. So what if x is greater than or equal to -1 and less than 0? Then we should get -1. And if we add that to 3, we'll end up getting 2. So we go to y is 2. And hopefully by the by visually inspecting the pattern here, it would make sense that we're going to say that when x is -1, we're at y equals 2, and we do that almost until we get x to 0, and then we put the open dot. So again, x -1 to almost to x 0, we're at y is 2, and that's what the graph represents. Okay, let's try one more thing with greatest integer function. So what if we multiply x times something and then do the greatest integer function, like y equals greatest integer of 3x? I've decided to make 3 separate columns so that it's clear to you what's happening here. So what are the kinds of things that we're curious about? First of all, I guess we might say, well, what happens when 3x is greater than or equal to 0 and less than 1? The reason why I say that that's what I'm interested in, it's because the greatest integer takes you down to it takes you to the largest integer that's less than or equal to x. It rounds down to the nearest integer. So it wouldn't make sense to go from x is 0 to 1. What we want to know is whatever is inside these brackets, we want to know what happens when they go from 0 to 1. So I start with the 3x being between 0 and 1. And then to figure out what my x values are, then I could divide through by 3. So I divide by 3, divide by 3, divide by 3, and when I do, I get 0 is less than or equal to x, and that is less than 1/3. Now that really doesn't belong in this column. It's really supposed to go over here. 0 is less than or equal to x, and that's less than 1/3. And we can go ahead and scratch that off. That's not necessary anymore. So it turns out when 3x is between 0 and 1, we would expect 3x to be equal to 0. We'd expect greatest integer of 3x to be 0. So when 3x is between 0 and 1, we expect y to be 0. Okay, but what's x? X is between 0 and 1/3. So for that reason, what we do is we go over here and we draw when y is 0, x is between 0, and I go about 1/3 of the way out and I do an open dot. And then let's see what happens when we go 3x is between 1 and 2. So 3x is greater than or equal to 1 and less than 2. Again, we divide both sides by 3, and when we do, we get 1/3 is less than or equal to x is less than 2/3. If I divide this 2 by 3 and this 1 by 3 and this 3x by 3, I get this. So what it's saying is we go between 1/3 and 2/3, and since 3x is between 1 and 2, then y is going to be 1. So when y is 1, we go between 1/3, close dot, all the way up to 2/3, open dot. And I'm not graphing perfectly accurately because my squares are too small. And then we'll do one more just for fun. What if we go between 2 and 3? Then we divide both sides by 3, so we get between 2/3, and 3 divided by 3 is 1. So, and again, because we're going between 2 and 3, this by the way matches up with this. This matches with this, and this guy right here, the y value is going to be 2, because if we round down any of these numbers between 2 and 3, we're going to get 2. So when we go to y is 2, we get a closed dot at 2/3, and we go all the way up to 1, except we don't touch 1. So this is kind of what the graph looks like when we do greatest integer of 3 times x. Alright, so that's the greatest integer function.